Hi guys, here we are, section 8.1, confidence intervals for a population mean. This is question number 59 and I'm looking at parts C and D. Not copyright, just part C, whatever, we'll just leave it. This video will make more sense if you also just looked at the previous video where I do part B, but here we are. Maybe you got part B just fine. So this is looking at the number of Wii games sold and trying to estimate the population mean number of Wii games sold. So here we are, Super Mario and Michael Jackson and Lego Star Wars and Zumba, things that never go out of style, ha ha ha. Part C, here was part B, looking at the confidence interval, la 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 la. C. Calculate and interpret the margin of error. So to calculate and interpret the margin of error, here is the formula again. We're writing x bar plus or minus z critical, or z alpha over 2, times sigma over the square root of n. So this part here, that's the margin of error. Margin of error. It's hard to say error clearly without sounding like a robot, so sorry about that. So we just want this part. This is the margin of error, just that right there. So we have to quickly figure out these various pieces. Z alpha over 2, that is 2.576. Where is 2.576 coming from? That is our 99% from this table. You just use this table. You will have this table on the test, so don't worry about that. Unless you're not taking my test and you're in a different class, then I guess you have something to worry about. So sigma, which was the population standard deviation, is 30. Remember it says 30,000, but we're just using 30 to be consistent with the numbers that we had before, and n equals 8. So the margin of error, M-O-E, the MO, is 2.576 times 30, all divided by the square root of 8, square root, which is equal to roughly 27.322 thousand. Remember, these are in terms of thousands. Thousand, like that. So the question asks you to construct and interpret, sorry for the scrolling, close your eyes till I'm done, here it is, calculate and interpret the margin of error. So we calculated it to be 27.322 thousand. Now we have to interpret it. Here's your sentence for interpreting the margin of error. We can estimate the population mean number of games, so you want to fill this in for your particular situation, to within 2.365. Why did I say 2.365? Or 27.322 thousand games with 99% confidence. So this, again, we can estimate the population mean number of games to within whatever number you calculate here with 99% confidence. So if you need to write a sentence that is the interpretation of the margin of error, this is the sentence you want to remember or write down on your card. Let's look at part D. Hold on, I'll make a new picture. D, as in delta, says how large a sample size do you need to estimate mu, the population mean number of games sold, to within 5,000, see it's doing that tricky thing again, 5,000 units with 99% confidence. So here's how you do it. I'm going to write this formula down again, although we don't really need the whole formula. X bar plus or minus z alpha over 2, that's the critical value, times sigma over the square root of n. Okay, this part here, that's the margin of error. We just looked at that. And they're saying we want to calculate this to within 5,000 units. So that's saying we want to calculate it to within 5. Remember, because the way that they're using the numbers, they're all in thousands, so we'll say within 5. So we want x bar plus or minus 5. So this whole thing right here, we want this to be equal to 5. So the margin of error is 5. So essentially, for these problems, when they say within something, that's the margin of error. So you want to set this up so that you have 5 is equal to, and then you plug in this part, z alpha over 2 times sigma over the square root of n, and we're trying to find n. We're saying what n do we want? So we know that z alpha over 2 is 2.576, because that was 99% confidence, is 2.576. We have sigma is equal to 30,000. Remember, it was 30,000, but everything's in thousands for this problem. And n is what? Some of you are probably thinking, I thought n was 8. Isn't n equal to 8? No, because that was for the previous sample. So now we're saying if we were going to do it again, what sample size would we need? I'm going to go back to white. 5 here. So now we want to solve this problem here for n. So you put square root of n on the other side, and you get 2.576 times 30, all divided by 5, which is equal to 200 and, oops, I kind of jumped ahead here. That's equal to 15.456. So I'm saying square root of n equals 15.456. We square both sides to get rid of the square root. So I get n is equal to 15.456 squared, which is equal to 238.887. So how large a sample do we need? 238.887. So I would round that up to 239, roughly 239. So if you go back to the problem, how large a sample size? 239. That answer is fast. No weird interpretation there. So we basically have to sample 239 in order to get an estimate sample size, to estimate the mean number of games sold. Alrighty, that's it, you guys. Off to section 8.3.